Good day, learners! Welcome to Math Corner's General Mathematics for Senior High School, Episode 5, entitled Composition of Functions.
Let us learn first the definition of composition of functions. When the output of one function is used as the input of another, we call the entire operation a composition of functions. For any input x and functions f and g, this action defines a composite function, which we write as f composed with g, such that f composed with g of x is equal to f of g of x, such that this function can be read as f composed with g of x. However, this function can be read as f of g of x. Take note, in general, f composed with g and g composed with f are different functions. In other words, in many cases, f of g of x is not equal to g of f of x. We will also see that two functions can be composed only in one specific order. For example, if f of x is equal to x squared and g of x is equal to x plus 2, then case number 1, f of g of x is equal to, replace g of x by x plus 2, which yields to f of x plus 2. Since the given f of x is equal to x squared, replace x by x plus 2, which is the new input of the function f. That means we have x plus 2 squared and expand the binomial, which yields to x squared plus 4x plus 4. On the other hand, case number 2, g of f of x. Replace f of x by the given x squared, which yields to g of x squared. What does it mean? X squared, or the function f of x, is now the input of the function g. Since the given g of x is equal to x plus 2, we will replace x by x squared, which yields to x squared plus 2. Since we cannot simplify this one any further, this is now the value of the function g of f of x. In evaluating composite functions using formulas, there are two steps that you have to follow. First, evaluate the inside function using the input value or variable provided. Second, use the resulting output as the input to the outside function.
Let's take a look with our example. Given f of x is equal to 3x plus 2 and g of x is equal to x plus 5. Now, since we are already finished answering or discussing about how to evaluate functions in our previous discussion, so I hope you can apply that concept that you have learned from the previous discussion to our topic for today. So, first is we are going to solve for f composed with g of x. Now, what does it mean? We are going to write first the general form for this function, which is f of g of x. Now, what does it mean? Now, it means that the g of x, the function g of x, is the input of the function f of x. So first is we are going to substitute the value of g of x going back to our given. The g of x is equal to x plus 5. That's it. Now, since our f of x, going back to our given, f of x is equal to 3x plus 2, we will replace all the variable x with x plus 5. So that means we have x, or f of x plus 5 is equal to 3 times. Replace x with x plus 5. That means x plus 5 plus 2. And then simplify. Distribute 3 to the two terms inside the parentheses. That means we have 3x plus 15 plus 2. And then combine similar terms, which is 3x plus 17. Therefore, 3x plus 17 is our f composed with g of x. How about our second function? We have g composed with f of x. Now, as we all know, f composed with g of x is different from g composed with f of x. Why? Because here, in the first question, the g of x is the input of the f of x. Whereas in the second question, the f of x is the input of the g of x. It's the opposite. So therefore, we are going to take first the general form, that is g of f of x, and then replace f of x by, going back to our given, g of 3x plus 2. And then here, what does it mean? 3x plus 2. 3x plus 2 is the new input of the function g. Therefore, going back to our given, g of x is equal to x plus 5. Replace x with the new input, which is 3x plus 2. So g of 3x plus 2 is equal to, replace x with 3x plus 2. That is 3x plus 2. And do not forget plus 5. Plus 5. And then combine similar terms. That means we have 3x plus 7. Therefore, 3x plus 7 is the value of our second function, which is g composed with f of x. Let's take a look with our example number 2. Given f of x is equal to x squared plus 6 and g of x is equal to 2x minus 1. Now, A, we are going to find first f composed with g of x. Now, the same process with our previous example, we are going to find first the general form of this function, which is f of g of x. And then we have to replace or substitute g of x with the given. We have 2x minus 1. So we have f of 2x minus 1. After this one, we will go back to our given function of f of x, which is f of x is equal to x squared plus 6. As I said, we are going to replace this one with 2x minus 1, which is our new input. That means we have f of 2x minus 1 is equal to, replace x with 2x minus 1. That is 2x minus 1 squared plus 6. And then expand this binomial. This is 2x minus 1 squared, which is equal to 4x squared minus 4x plus 1 plus 6. Do not forget the plus 6. And then simplify, which is equal to 4x squared minus 4x plus 7. So therefore, 4x squared minus 4x plus 7 is the value of our function f composed with g of x. How about our second question or second function, which is g composed with f of x? The same here, we will find first the general form, which is g composed of f of x. After this one, we are going to replace f of x with the given, which is x squared plus 6. That means we have g of x squared plus 6. Going back to our second function, which is g of x is equal to 2x minus 1. Replace x with x squared plus 6. That means we have g of x squared plus 6 is equal to 2 times, substitute x with x squared plus 6. That is x squared plus 6 minus 1, which is equal to, distribute 2 to the terms inside the parentheses, which is equal to 2x squared plus 12 minus 1. And then simplify. So we have 2x squared. 12 minus 1 is equal to 11, which is plus 11. Therefore, 2x squared plus 11 is the value of our function g composed of f of x. Let's have the last example. Given f of x is equal to square root of x plus 2 and the g of x is equal to x squared plus 3. Now, first is we are going to find first we have f composed with g of x. So we will write first the general form, which is f composed or f of g of x. The same with the previous example, we will replace this one or substitute this one with the value of the g of x in the given, which is f of x squared plus 3. And then going back to our given, f of x is equal to square root of x plus 2. Replace x with x squared plus 3, which is equal to x squared plus 3 is equal to square root of x squared plus 3 plus 2. Okay, since we cannot simplify this one any further, therefore, square root of x squared plus 3 plus 2 is the value of our function f composed with g of x. How about our second function, which is about g composed with f of x? Now first, the same with the previous examples, we have here g of f of x. And then replace f of x with a given function, that is g of square root of x plus 2. And then copy our g of x. We have g of x is equal to x squared plus 3. Replace all the variable x with our new input, which is square root of x plus 2. That is g of square root of x plus 2, which is equal to square root of x plus 2 squared plus 3. And then expand this binomial. Expand this binomial square root of x plus 2, which is equal to x plus 4 square root of x plus 4 plus 3. And then combine similar terms, combine the constants. We have x plus 4 square root of x plus 7. So since we cannot simplify this one any further, x plus 4 square root of x, they are not similar or they are not the same terms. That means x plus 4 square root of x plus 7 is the value of our second function, which is g composed with f of x.